Greetings, this is Unit 5, Module 2, Session 6. The name of this home connection is Classifying and Drawing Quadrilaterals. Place your name and number at the top, and let's begin. First off, it's important to know that quad refers to 4. Like some people live in a quadplex, which is like 4 apartments together. When you go to college, you might live in a quad, which has 4 bedrooms. Your legs have quadriceps in them, which is made up of 4 groups of muscles. So that word quad is very important. A quadrilateral is any polygon that has 4 sides. Okay, and there are many kinds, including all of these. Let's take just a real quick look at them. First, the trapezoid. The arrows refer to parallel, just so that we're aware. And then the hash marks refer to congruence. So that means the sides with 1 hash mark are the same length. The sides with 2 hash marks are the same length, right? So this says that the opposite lines are parallel, but only one pair. It is not a trapezoid if both sides are parallel, because if it is, it would either be a square or a rectangle, right? So a trapezoid is unique in that the 2 sides that are parallel will not be the same length, okay? There's a little bit more that goes into it, but for now, let's go with that, okay? The rectangle, which we know, it has 2 pairs of parallel sides, so the opposite sides are parallel. They'll never touch. If they went on for infinity, they would never touch. And then the other 2 opposite sides are parallel. They would never touch, okay? As a result, they make perfect right angles, which are 90 degrees, right? And so there's going to be no obtuse or acute angles in there. They're going to have these precise 90-degree angles, okay? And then just go down to square, just because we know that all squares are rectangles. The only difference is that a square has to have sides that are all the same length, which is why they put that single hash mark on those to indicate that all of them are the same length. Okay? Now, let's demystify this just a little bit, the rhombus versus the parallelogram. If you were to take a square and squish it so that it kind of leaned over, maybe think of it if this was flat and you squished it over, you would end up with a rhombus. All 4 sides are the same length. The difference is that you have no 90-degree angles. So you're going to end up with 2 obtuse and 2 acute angles in every rhombus. How does that change when it comes to a parallelogram? Well, it would be as if you took a rectangle and you squished it over. If I were to lengthen these sides here so that they were the exact same as the top and bottom, so it would be quite a bit taller, I'd end up with a rhombus, right? Because it's a quadrilateral with 2 pairs of parallel sides, right? So the opposite sides are parallel. That's what my arrows indicate. But only the opposites are the same length. So let's say like this is 4. Well, you know what? We could actually measure it so that it makes sense. So we've got about, 5.5, 5.5. And then if I measure here, it's to be about 2 centimeters and 2 centimeters, right? This, on the other hand, is probably like 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters. That's the difference between our rhombus and our parallelogram. It's the only difference is that all of the sides are the same, and then the pairs are the same, okay? So think of it as like a squishy square, a squishy rectangle, okay? Now let's move on. I did a little bit of discussion there, but it's so important to know the difference, especially if you're going to look at diagrams, and then answer questions about them. Holy moly! So it says, look carefully at the figures. You're going to decide how many right angles, how many pairs of congruent sides. Congruent is that fancy word that means equal, right? And how many pairs of sides are parallel, right? So these 2 are parallel. That's 1 pair, because a pair is 2, right? These 2 are parallel, so that means there are 2 pairs of parallel lines, okay? So let's go, right angles. Why don't we identify the shape first? This looks kind of like a squishy square or a squishy rectangle, but we can be precise if we wanted to. This is 1 centimeter, 1 centimeter, yeah. So all of these sides are equal, so I could go like this. Boop, 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 make my equal marks. And then it does look like these two sides are parallel, so I'll do my little arrows as well. Doo-doo-doo. Maybe I should zoom in. It seems like it's pretty far away. And then I'm going to do my kind of my double arrow, because these are a different set of parallel lines. So it might look messy, but in my brain it works out. So opposite sides are parallel. All of the sides are the same. Ta-da-ta-da! Looks like we're looking at a rhombus, which is an option for my first one. So I can go over here and I can circle the word rhombus, and then I can answer the questions about it. Right angles? None. Pairs of congruent sides? 2 pairs. Yeah, because same. Oh, pairs of parallel sides? 2, because we said the opposite sides are parallel. That's kind of why we drew those arrows, to indicate they're parallel. And then we circled what it is. Yay, good for us. Okay, as I move into the next one, it probably looks like a pretty common shape that we know. Looks like these sides are parallel, so I'll do that little arrow marking so that show that they're parallel. This line looks like it goes here. This line looks like it goes there. If I were to continue drawing these lines, like if I made that line continue, and then I made the other line continue, they do meet, don't they? It would kind of make kind of a triangular shape. So I know that these opposite sides are not parallel. Okay, there's only one shape that works like that, where you have one pair of parallel sides, but not all the sides are equal. Okay, and we decided that that was the trapezoid. Exactly one pair of parallel sides. So I can go over onto my chart, find my trapezoid, circle it, and then we can answer the questions. Pairs of parallel sides? 1. Pairs of congruent sides? We don't technically know that unless we measure, but I guess I could do that real quick. That appears to be 8 millimeters. 7 millimeters actually. And that is, oh, that one kind of looks like 9 millimeters. So none of the sides are congruent. And then right angles, also none. Or else I would have like those lovely square markings, right? There's no angles in there that would make a square or a rectangle. Okay? Now, I look at this shape. I'm going to kind of actually look at like this. This kind of looks like a squishy rectangle. If I were to go in here and measure, and let's see, that's about 7, 5, 10, 11, 12, maybe 13, and 13, okay, by, that looks like about 7 and 7. Okay, so the opposite sides, if I wanted to keep marking it, this side looks parallel to this side, okay, and this side looks parallel to this side. This is the same length as this, and then I know I'm going to have to squish these marks in here, but bear with me. This side looks the same as that side. I put double marks there, right? So, what is that? Well, it kind of looks like what I just drew here. Parallel, parallel. These two sides are the same length. These two sides are the same length. We call that a parallelogram. So I go through here, circle that, and then I can answer my questions. How many right angles? None. How many pairs of congruent sides? 2, because we said that pair is equal in length, this pair is equal in length. Pairs of parallel sides? 2 pairs of parallel sides, because we said this moves in the same direction as this side moves in the same direction as that side. They'll never touch. They are parallel. And then when I go to the end, then I'm going to do shapes that all are created from the same initial line. So what does that look like? Well, they did an example. It said, draw a square. This was the line that they were given, and then they finished it by counting the number of squares. 1, 2, 3, 4. And so they went 4 out, 4 down, 4 in, made a perfect square. However, they want a parallelogram that is not a rhombus or a rectangle. Man, what is that? A parallelogram that is not a rhombus or a rectangle? Do you have an idea? If I look at my chart, so I'm saying a parallelogram that is not a rhombus, it's not a rectangle, I'm going to have to make sure that opposite sides are congruent and parallel. Opposite sides are congruent and parallel. So what if I tried to make a squishy rectangle? Okay. So this is the line they gave me. It's 4 tall. Okay, four squares tall. 1, 2, 3, 4. I need to make sure that this line, wherever it goes, the next line, is not a right angle, so I can't turn exactly right. And I also can't go exactly 4 squares. So maybe I want to make it longer than that. And then, so that would be like going 1, 2, 3, 4, but then I go up maybe 1. I could go up maybe 2 and make it a pretty long line. I could even go up 3. But let's see what happens. I'll connect my dots here. And then whatever that is, since we're making a parallelogram, I have to do the exact same from this point here. So I went 1, 2, 3, 4, 1, 2, 3. So I need to do the same thing from down here at this starting point. 1, 2, 3, 4, 1, 2, 3. Draw my point, and then finish my shape. As a result, I now have a parallelogram. It's not a rhombus, because these up and down sides are not the same length as my diagonals. Okay, so that is a parallelogram that is not a rhombus or a rectangle, because these are parallel and they're the same length. Yes, these are also parallel, but they are a different length, which is why I use 2 hash marks to indicate they're congruent but not the same as these. Okay? Next it says to make a trapezoid. We know that a trapezoid has to have 2 parallel sides. Okay? Do I want to try to make it match maybe the parallelogram that's here and have the top and bottom be parallel? We can do that. But what do I need to make sure? This is 4 tall. That's okay, but we just can't make the line on the right side also be 4 tall, or else I'm going to end up with a square or a rectangle, right? So if I'm going to come over, let's say, 3 squares, what am I going to have to do for the bottom? It's going to have to be 4 or more squares, because the parallel sides have to be a different length, okay? So let's do that. Let's go maybe from this point over, we'll go over 3, 1, 2, 3. And then choose a number that's either smaller or bigger than 3, because it can't go to 3 or else you'll end up with a rectangle. We don't want that. So let's say 1, 2, 3, 4, 5. Is that okay? Yeah, because you could do here, 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 here. You just can't. There's only one place you can't be. Okay? Then if I connect my dots, it should start to take shape. Haha, pun intended. But more importantly, it's going to take the shape of a trapezoid. So there we go. I have my parallel sides. I'll mark here. None of the sides are the same length. So this is short. This is shorter than this side. This is shorter than this side. So that is a trapezoid. I only have 1 pair of parallel sides. Finally, and I know I've been doing a lot of these with you, but it is so important to have a guide as you do these. So if at any point in time you want to just do these on your own, please do. Or if maybe you want to try it first and then watch the video, go for that too. So if you want to pause this video, you could do a rectangle that is not a square. All right? And this one, I think I am going to let you do on your own, but I'm going to get you started, okay? We know that a rectangle is not a square if 2 of the pairs of parallel sides aren't the same length, right? When you see a square, every side is identical. Maybe it's 4, 4, 4, and 4. I'm just guessing on the measurement. But on a rectangle, it would be like 4, 8, 4, 8, right? So we need to make sure that 2 of the other lines are a different length. So if this is 4 tall, I can go out 3, I can go out 5, I can go out 6, I can go out 2. I just can't go out 4, because if I go out to 4, then I get a square. So when you make this rectangle, just make sure it's not 4, 4, 4, 4, and you're good to go. Okay? Which of your shapes above has the largest area? Uh-oh. How can you tell? Well, I didn't do one of them, but let me back out so we can see all the shapes. So which ones have the largest area? Well, this square, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, that's 16. I know that. I could have also taken, 4 times 4 to get 16 because area, area is height times width, right? How tall something is by how wide it is, okay? But in some cases, this is really hard to do, right? Because I might look at these squares and go, oh my goodness. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, but then I have all these partial squares, and maybe that's 11, 12, 13, 14, 15, 16, so maybe that's 16-ish as well. Oh, that's interesting. And I'm just kind of guessing, right? And then I might count this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we'll say 13, 14, 15, 16. Oh, interesting, that's also about 16. But you know what, maybe I better finish this last one so I can actually find one that is larger. And I'm going to take this one all the way out. So that I have, this is going to be hard to do this side, but I'll do my best to make it dark. And then I look at this one. It's 4 tall, 1, 2, 3, 4, 5, 6 wide. 4 times 6, 24. Ha-ha! So which of my shapes is the largest? Well, it's going to be this one. How do I know? Because I counted the squares. Ha! Yay! And hopefully you are too, okay? Your answer might be different. You may have made this a huge parallelogram. Or maybe you made this a teeny tiny trapezoid, and that wasn't an option, right? So as you go through your shapes, make sure you think to yourself, how many squares does that take up? That's going to be your area. As usual, if you have questions, ask a math wizard. We love to answer questions about math. It is so much fun, and we like to be able to help. So please ask someone. Otherwise, we'll check you later.